G'day, I'm Greg and welcome to the shed. It's mid-30s in the shed today and I'm noticing it. We had a few boys around here yesterday. We had Bruce with them from Gemtrek, Mr. Getter Out, who a lot of you will know. JB from Oz was here with his father. Troy was here. So we had a bit of a get-together of YouTube machinists, and Bruce will probably be putting a video up on his channel in the next few days, hopefully. But I'm off out bush again, or back out to site again tomorrow. But before then, I've got a little job that I need to do, which we'll talk about in a minute. Actually, look, let's start talking about it now. I'll put my glasses on so I can see it. I'm a bit dehydrated. What we have here, actually I might just swing you around and down. What we have here, this is a drive hub, it is a drive hub off a on-vehicle brake lathe, and it's been dropped. It's a two-piece hub now instead of a one-piece. So what we have is these here go onto the hubs, onto the wheel studs, and you mount your machine on the outside here, and then it machines the disc off, which is on this side here where my finger is, which is the back side. No doubt there's some videos on vehicle brake lathes. They're all basically the same. So what we've got to do is we've got to either make a new hub completely, which isn't that hard, or we can try fixing this one, or we can try buying one. This belongs to a mate of mine, very good mate. I've known him since we were in our mid-teens, and consequently I think it's time to punish him by fixing another thing that he's broken. Although, if I'm going to be really honest about it, it was actually broken when he bought the machine, but we won't let him get away with that. Never let a chance go by. Now, this has got little spring clips on these arms. I've already knocked this one off, this one out. They use a press-in pin, which is, it's, in the words of someone else, focus you flame on camera. Oh, that's the Australian translation of it anyway. So what we'll do is we've got to take these pins out because we don't want them to go soft. We'll take these cap screws out because we don't want them to go soft, and we don't want them to bind up. Now, because it's cast, I'll be doing a bit of preheating on it. But I've got to make a decision on how to weld it. Now, I've got a couple of options, or actually I've got more than a couple of options. I've got some silicon bronze. I've got some manganese bronze. And I've got some cast iron arc rods. Now, I've got the TIG welder, so it'll be TIG brazed, or it could be DC arc, it could be AC arc, or the other option I've got is I could knock the flux off the arc rods and just use those rods as a filler and TIG it in. So that's another option. Now, what I'm not going to do is I'm not going to use the manganese bronze, because with the TIG, what it does is it seems to boil the manganese out, and it sputters and hisses and fits all the time, and yeah, look, you end up with a pretty good result, no doubt at all about that. Or I did last time I did it, but I didn't like it. Silicon bronze, that will be, in this case it's going to be the fallback, and you've probably guessed that I'm leaning towards using the arc rods. Now, the rods that I've got are not quite as old as I am. it's over 30 years old. They're over 30 years old, so the flux on them's not going to be any good. So I'm not going to arc it. What I'm going to do is I'm going to try tacking it up with the using the TIG and the cast rods as a solid filler wire. And we'll see how it takes this material, because we know it's cast. We don't know how good the cast is. I don't even know what brand of machine it's come off. What I do know is that he bought it for a particularly good price, and the machine wasn't very old, so the initial purchase price to the owner was probably quite low. So yeah, I can speculate, you can speculate, but I can't elaborate because I just don't know. So the next question is, what's all this rubbish? These are Hebel bricks. Hebel are the people that, well, they're a CSR product in Australia. Hebel's the brand they market them under. I think Hebel's actually a brand name, and they're manufactured under licence. They're aerated concrete. So what I've done is I've set them up on my bench for a couple of reasons. I want to preheat this, and I want to keep the heat in it while I'm working on it. So when I preheat it, I can preheat it back here, and I can do a bit of welding on it. And I can hear people cringing already, going, but it's not flat. And you're right. But the question is, how flat do I need it? Now, before you start any job, the question is, what are your critical dimensions? What are your critical things? In this case, these slots here and here, they need to be pretty close to the right point. This outside diameter is not really critical, because we have these swinging arms here. Let's stand it up. These swinging arms here, the wheel studs go through here. This is for a 5-stud wheel. So these will all find their own reference points. The actual critical part is where these are located. So what I have to do is I have to make sure that this piece here ends up as close as I can get it. This outside face here isn't super critical. Well, I say it isn't super critical. The dimension from the back to the front isn't super critical, as long as it's somewhere near parallel. And I say that within machinist terms, not within woodworking terms, and there's no criticism to chippies, because wood is a constantly moving medium or product that you're working with. It is never the same dimension twice, because as the humidity changes and the age of the product changes, your dimension changes. When we're working with steel or cast, same sort of thing. At the moment it's mid-30s in the shed. It's 30 centigrade, not 30 Fahrenheit. If it was 30 Fahrenheit, I wouldn't be wearing just a shirt. I might be a little overweight, but I haven't got that much insulation on me. So, providing this is, within a couple of tenths of a millimetre, 10, 12 thou, it's just not going to matter in the big picture. The other thing here is, and this is where it's a good idea to actually understand what you're working on. This face here does not have to be parallel to this face here where the machine mounts to, despite the fact it's a lathe adapter. Because what happens is, once you mount the machine up here, it's actually got some jacking screws so that you set it to true. So it runs true, and then it machines the disc to true, because you can't rely on the hub that this is bolting to actually be true. Actually, to turn you off, I'll go and grab one and show you. Okay, I've decided not to grab one, I grabbed two, because there's an interesting little thing here that I'll show you. These have been replaced. These are off an Australian manufactured or no longer manufactured in Australia, Ford Falcon. But it's atypical of these types of things all over the world. Build up of rust on the surface. That's where the disc brake itself mounts onto. And then this here would actually mount on the outside when I get it in the right spot. It'll mount on the outside, bolts through, so we end up something like that with the disc sandwiched in here. But so these get a build up of rust and stuff on them, and it'll kick the adapter off before you even start. People over tighten them. They're quite thin. What happens is it buckles behind here. It relies on having the disc on the front of it to hold it, or to add rigidity to it. I was about to say to hold it true, which it does. It adds rigidity to it. So what it does is that effectively it sandwiches the disc in here, adds stiffness and load carrying capacity. But the problem is that some will rattle this stud up real tight, and then this one, instead of just nipping this one and then nipping that one and then coming back and nipping this one, and by the time you've got those three nipped, this one here and this one here are probably pretty close to seated, and then you can actually start laying into them and getting them somewhere near torque on your first run. But generally what happens is the boys, they get paid bonuses for knocking jobs out in less than book time. So they lean on this one, it's tight. This one becomes tight, that one becomes tight, that one becomes tight, that one becomes tight, that one becomes tight. So what it does is it just stresses the whole lot of it. This one's tight and it's bent everything because nothing's pulled up over here. There's a bit of clearance, bit of dirt, and you just crush it all in. It is an issue. You're getting paid for, when I say you're getting paid, the boys in the workshops are getting paid for knocking jobs out in less than book time. They get paid incentives to knock them out in less than book time. Yes, you can say they're at fault, but the question is, are they at fault, or is it the incentive program that is creating the issue? I have a significant issue with incentive programs because most of them are designed by people who think they know, but they don't understand the consequences of an incentive. But yeah, that's basically what it mounts up to with the disc brake in between. Now, while we're talking about this, these did about, what do these ones do? About 250,000 kilometres, 250,000 k's, and they got noisy. Now, you'd say, throw a set of bearings in them. You can't. These are a cast steel, and they're induction hardened by the looks of it, and then ground, precision ground to dimension. I haven't got the balls. That's a bad term, but you take that as you want it. This is actually the bearing race inside here. The ball bearings run in here, and on the other side they run in here. So it's actually this whole thing is actually a bearing. Instead of this is actually the outer race of the bearing, and your wheel bolts to it. Now what's happened is that, trying to get it so you can see, this dark spot in here, that's where the hard facing's worn out. It's gone through the hard facing, and as you're going down the road you get rrr, 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 rrr. Yeah, I know. You get rrr, rrr, rrr noise, and it's quite easy to pick. As you go down the road, you turn the wheel a little bit, and it goes rrr, 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 and then you turn it back the other way, and it goes quiet. And so you can identify whether it's a right-hand wheel bearing or a left-hand wheel bearing. Front or rear, the same rules apply. So it helps you narrow it down. I'm just looking at the inner races. These are the inner races. They actually have this steel sleeve on them. It's a dust sleeve. The bearing sits in a plastic cage. The roller ball bearings in a plastic cage, and then they're cleverly pushed together. And when they're fully assembled, these faces here actually, you do them up tight, and these faces here actually are up against each other, and it's compressed tight, and that applies the right amount of preload to this so that it doesn't wobble and give you brake pad knockoff. They're pretty cleverly made, but yeah, we've digressed for 10 minutes. So what I'm going to do now is I'm going to knock some of these pins out, and we'll get on with doing a bit of welding. So I'll set you up. You can watch me knock a pin or two out, because it's you probably don't want to watch me knock all of them out, and we'll get on with it. Now there's a lot of different ways stuff can be removed, and quite frankly a press would probably be a good thing. But, and yes, I do have a press, but what I'm going to do is I'm going to do it this way, because this would be a typical way that you can do it at home. Now, there's a couple of things I've done here which are actually, now that you see me do one, what I've done is I've made sure that I haven't hit the spring clip. I have supported it on the flat faces of the vise. I'm drifting, the drifter's going in onto the back here, and the drifter's small enough that it's got plenty of clearance, and it actually sits nicely in this recess that's just in here. It actually finds its own centre. Now, the reason I've got these stuck out, these arms stuck out as far as I can, is what it does is it gets me closer to the centre of the vise. I'm putting my little finger through the hole here, knowing full well that this isn't heavy, or I say this isn't, that what I'm trying to catch isn't heavy. As soon as I get down a little bit, the end of the punch is actually divided. Now, warning. The warning is, if you drop this and your finger is in here, you will break it. Make sure you don't drop it. If you don't break it, you'll dislocate it. So, put my finger in to hold it. That pin came right out. Now, my stomach is holding that up against the vise. I've got both hands in camera shot. It's still on the vise, it's pinched in. Make sure you have control of it. If you don't have control of it, don't bother telling me about your broken fingers. At the end of the day, we're all responsible for our own actions. See, again. Interestingly enough, that one hasn't even got a spring clip on it. So, it's a bit tight. So that's how you can get them out. That this comes out, looks like M6s by the looks of it. So, just screwing these out by hand. So we've got these here. They're out. Someone might be able to cast some light on it. This adapter number is actually 045. I don't see any brands on it. I'm just looking to see if there's any other damage. There's no other sign of breakage. There's a slightly better look. So we've got this face here to work with. We've got this face here. We've got this face here. We can't just stick this in and the right way up, that is. We can't just stick this in like this and weld it nicely up to the broken bits. What we've got to do is we're going to have to do a fair bit of V'ing out. We're going to have to tack it So what I'll probably do, my thoughts at the moment are, that's a bit of white paint there, that's not, what I'll probably do is I'll probably clean this up here, and here, and here, and I'll just do some edge tacks, 1, 2, maybe 4 edge tacks, and then we'll get some good, we'll get some good bees in here, front and back, so that I've got something to fill with the welder. So we're going to have to try and do something about duplicating this here. So we're going to have a face that we can dial in on. This face just inside the lip here is machined. That's machined. Oh, you can't see. Sorry. Here's machined. Okay, let's try again. Let's get it again. There's a machined step here, another one here, and we're rough cast as we get to the bottom of the hole. Yeah, you can see we're rough cast here, we're machined here, and then we've got a step just here on the outside. So we'll clean this up. I'll be back in a sec with the grinder. Okay, so I've got all my PPE off now. Earplugs out, gloves off. What I've done, there's not much there, but there's a bit here, there's a bit here, and you can only just see it, but there's a little bit there on the corner, which is there. My original break points, so I've got something to reference to when I offer it up to tack it. As it tacks and it takes, what I'll probably do is I'll probably get a weld in on the big parts of the bees, and then I'll make up my mind. I'll see how it goes when I'm doing it. What I'll probably do is I'll probably come back and V the rest of it out and get rid of my reference surfaces, V them out, and then do a proper weld on that in there as well, right? So if I've got it in the ballpark, that should now, and it does, it actually, you can't see. Let's try it again. Let's show it off again. Okay, what I was saying is, if I've got it in the ballpark, what this should do is when I push it together, it should, and it does, see it's found its a point where it doesn't want to move. It's all spot on right there. So what I'm going to do is I'm going to try and get maybe 4 tacks in, one here, one in this corner, one in this corner, one out here and one out here, while it's cold. So we'll see how we go with that. It's only a little bit. We'll do a cold weld on it, and then what we'll do is, if we can get it to take with the cast rods, what we'll do then is we'll put some proper preheat into it, because we know it's not going to move too much then. I can put some proper preheat into it, and we can get on with some real welding. And we'll see how we go from there. I'll be back in a little bit.